Hi, let's go ahead and do your in after journal. This is going to be 3, and this is going to be powers and radicals, and then radicals and powers. Okay, so what you're going to do is you're going to go ahead and take the orange sheet that I've given you and you're going to paste it into your journal. So once you have it pasted into your journal, it's going to be part of it. So let's go on to the second item. The second item you're going to do is going to be a foldable. So the foldables, some of them came out a little bit bigger than we anticipated, but you're going to go ahead and glue those to the side. Okay, so we've labeled all our tabs all the way to 4. I want to talk about the Pythagorean Theorem. It's a squared plus b squared equals c squared. You need to have this on your foldable. You're going to draw out the right triangles. Remember, these two are legs, and this is the hypotenuse. And again, these two are legs, and this is the hypotenuse. Okay, I want you to notice there's only one c, and in the Pythagorean theorem you have c squared. So let's talk about how to find the hypotenuse, which is equal to c. So up here, we're going to talk about the right triangle. And I'm going to give you some dimensions. I have an 8 here, a 6 here. And what I want to do is I want to find the hypotenuse, or C, because those are the same things. And I know that I have A equals 8, B equals 6, and C I'm not sure of. So with Pythagorean theorem, it's a squared plus b squared equals c squared. So now I'm going to have 8 squared plus 6 squared equals c squared. So right here I'm going to have 64 plus 36 equals c squared. I'm going to add these. So I'm going to have 64 plus 36 equals 100 equals c squared. So right here, you're going to take the square root. Of both sides. And this is the last step. And then you're going to say that c, the square root of 100, equals 10. So you're going to say the hypotenuse equals 10. So if we go through each step, and I had to write this out, step 1 would be to find the sides. So we're going to label what I know. So the first step is to label. It's an E. And then my second step would be to substitute. And then my third step would be to add. And my fourth step would be to take the square root of both sides. And then number 5 is going to indicate solution. Okay, so the written part would be label, substitute, add, take the square root of both sides, indicate solution. But if you're going to have a written instruction, you're going to need to provide the mathematical reasoning behind it. Okay, let's go under our other tab to find a leg. So to find the leg is a little bit different. We need to think about what we're going to be given. So I'm going to draw another triangle. So this is what I'm given. So if I'm given B, then this is going to be A. If I'm given C, or 25, this is going to be C. So we go A equals 7. So I'm going to label. B equals my unknown, and C equals 25. Second step is going to be to substitute. And I'm substituting into Pythagorean Theorem. So it's 7 squared plus B squared equals 25 squared. And then I'm going to keep on working. So I get 49 plus B squared equals 625. I want to isolate B, so I want to get B alone. So I don't know what B is, so I'm going to isolate B. So to do that, I'm going to solve for B squared here. So minus 49 minus 49. B squared equals 576. That was step 3. Step 4 is going to be take the square root of both sides. So the square root of 576 is equivalent to 24. And the square root of B squared is B. And step 5 is going to be indicate solution. So indicate solution was 5. B is a leg. B equals 24, leg equals 24. Does that make sense? Both of these would be an acceptable solution. Okay, I'm gonna go ahead and use another Post-it, and we're gonna call this converse of Pythagorean Theorem. So converse Pythagorean Theorem, here's a definition. So the definition basically says if a triangle, remember it's a right triangle, has side lengths A, B, and C, and A squared plus B squared equals C squared, then the triangle is a right triangle. Okay, so we're saying that all of these are right triangles. So this is A, B, C, A, B, C. It keeps on going. as we define common Pythagorean triples. Okay, so that's an LES. So common Pythagorean triples are basically triangles that you know are going to work. We know that the a squared plus b squared equals c squared. So if I say a triangle is 3, 4, 5, I know that 3 squared plus 4 squared is going to equal c squared. So I'm saying 9 plus 16 equals 25, 25 equals 25. That's what we're saying. So the next one would be 5, 12, 13. So if I say 5 squared plus 12 squared equals 13 squared, 5 times 5, or 5 squared is 25, plus 144, which is 12 squared, equals 169. So it's 25 plus 144 equals 169. 169 equals 169. The next one we're going to talk about is going to be 7, 24, 25. Okay, so it's going to be 7 squared plus 24 squared equals 25 squared. So that's 49. 24 times 24 is 576 equals 25 times 25 is 625. 49 plus 526 is 625 equals 625. So this is also true when we're talking about the multiples. So we're talking about all multiples of these perfect Pythagorean triples are true. All multiples. So let's just say an example of a multiple. And we're going to do a multiple of a 3, 4, 5 triangle. So say I said all of that and we use a scalar of 4. So if I said that I had a scalar of 4, then you're going to say that's going to be multiplied 3, 4, 5. So that means that my triangle is going to be a 12, 16, 20. Remember, we're talking about A, B, and C. So if we prove this, 12 squared plus 16 squared equals 20 squared. Okay. So 12 squared is 144 plus 16 squared, which is 256, equals 20 squared, which is 400. So we can just show the work. So 400 equals 400. Therefore, this is a triple. Okay, see you in class.